to another episode of Math Snacks with Miss Lovely and Miss Wonderful. Today's episode is on the area of a circle.
I like circles.
I know, we just did the circumference one last week. Now we get to do area.
I know, and hopefully we all remember what we talked about last week because we're going to still use some of those same terms.
Well, I remember you said circumference is the distance around.
That's correct.
And I remember we said the diameter is the distance across.
Exactly.
So
and we talked about pi too.
Oh yeah, my favorite apple and
No, not those kind of pies. Let's just
okay. Pi is spelled P-I, no E.
That's correct.
Unfortunately.
That's correct.
And the symbol looks something like this.
That's correct. You remember a lot.
And
what's
approximately 3.14,
right.
Meaning the number of times the diameter can go around, which makes the circumference, is 3.14 times.
That's correct. You remember a lot from last week. I am proud of you. All right, well, we're going to talk about area of a circle today. So if you remember what we've talked about in the past with area, let's think back to area.
That's the like if I'm covering
the amount of space inside.
If I'm covering it. Okay.
Right. So we're going to do area, but we're going to refer back to an area that I know you already know how to do, and that would be area of a rectangle. Mm-hmm. So what are some of the different strategies that we could use to determine how much area or space is inside this rectangle?
Well, I was always told it's kind of like if this was your floor and you're laying carpet. And so I know if there's 10 across, 20, 30, 40, 50, 60. So it's 60 centimeters, square centimeters.
That's correct, because they all make squares when you go the length and the width. So you're right. It would be 60 centimeters squared.
And my teacher taught me to write it like that.
Excellent. Your teacher was right on top of it. The cool thing is even young kids could count the squares inside if you put your rectangle on grid paper. So
if they can't count by tens, they could go 1, 2, 3.
They could count like that way. And once they learn do arrays in multiplication, they know that a 6 times a 10 would be 60. So that's a skill that can work with smaller children or older children.
Or at the older level, it's length times width.
Exactly. They learn the formula. It's length times width. And we're going to use this length times width formula for area, but we're going to use circles. Now, that's kind of hard because think about laying a circle on grid paper. If you do that, if you were to lay a smaller circle, it would still be kind of tough.
Well, it would, because I can kind of see through to count some of them, but some of them are like, is that like half a square, a fourth a square?
You really can't tell. You really can't tell, can you?
No.
So we need to have a formula.
I could get approximate.
You could get approximately how many squares were in there, but you would not be able to get fairly accurate. And so if you had a circular room, which I don't know why you would if we use your analogy of carpet, because I guess they do have circular rooms, but so to get your floor,
you want padded.
So you would want to get fairly close on your estimate so that you could get the right amount of flooring.
How are we going to use length times width?
Well, we're going to cut the circle and try to make it look like your rectangle.
You're going to let me cut the circle?
I am going to let you cut the circle. I'm going to, if we know anything about fractions, they have to be equal size. So what are you going to do first?
I probably have to start doing something like this.
You're going to have to
make it equal
cut
size.
In half, right? And then you cut in fourths.
Can I do fourths? Because those would still be equal.
Can
I just take them as close as I can get them?
How about if you go to eighths to start with?
I think this is eighths, but let me open it up, make sure.
Okay.
Okay. Here we go.
Count them up.
1, 2, 3, 4, 5, 6, 7. Those are eighths.
There would be eighths. So if you cut them apart real quickly.
Still doesn't look like it's going to make a rectangle to me.
Well, guess what? By the magic of Snackovision, television, Snackovision, get it? It's going to look pretty close.
I'm sitting here going, Miss Lovely, you've lost it. I don't know what you're talking about.
You know, like television, the magic of television. You know how when they stick the food that's not cooked into the oven and pull out the cooked food?
Yeah.
Guess what?
Like?
There's your eighths, and it kind of, when you lay them that way, it's starting to kind of be like a rectangle.
It's definitely starting to look like a parallelogram.
Yes, exactly, which we know a lot about those too, but that's a whole nother topic.
Okay.
So looks kind of like a rectangle, and it's starting to be able, you're starting to be able to kind of see about how much it would fill. But guess what? If by the...
We got to do the snack-o-vision thing.
If snack-o-vision, and you cut to 1/16, it really starts to approximate a rectangle.
Now I could do length times width.
You could do length times width. So let's try that on this one. And we're going to be close. It's not going to be completely accurate, but it'll be close.
I'm going to take... Oh, this is actually width, and this is length.
Okay.
Okay. So I'm going to take kind of length times width.
Right. So what do you think that...
Can I just count the squares?
You could.
I could go like 1, 2, 3, 4.
Yes.
Like 4 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's kind of like 4 times 13.
Okay. So we could do 4 times 13 and get the approximate. Now...
But boy, to do that with every circle, you can't cut them up like that.
Well, yeah, because like what if it's the circle on the gym floor? We can't cut up the gym floor. So we have to figure out what these length and width really are in relationship to the circle. So let's go back to your original circle.
Okay.
Okay. And let's go back to eighths because I think you'll be able to... We could actually use the eighths that you cut apart earlier. Okay. Take one of those pieces and lay it on the circle and...
Probably ought to be different colors.
It should be, but we don't have a different color. Okay? Can you see it? Yeah, you can. Well, kind of, sort of. That length is the...
Oh, a new vocabulary word.
New vocabulary word. That length is halfway across the circle, halfway across the diameter, and that's a new vocabulary word. What do you... I know you know what it is.
I know it's radius.
Radius.
Radius. so
this length, this width that you called this side, this side was the width, is actually a radii.
Cool. How do you spell radii?
Actually, radii is plural. Radius. It's a radius.
Radius. Okay.
It's one
so the width is kind of the radius.
Yes.
So you're going to take the radius
times whatever we figure out the length is.
Okay.
Now, if we take these 1, 2, 3, 4 that are on this side and lay them 1, 2, 3, 4, which
can I do something?
You could do it. Oh, looky there. Oh, perfect. Good thinking.
Had them in 8. So
you had them in 8.
We have 4 of them.
Before I let you cut them up.
Yep.
And so there are 4 of them here. 1, 2, 3, 4. So you,
4 of those.
4 of those on your circle is actually...
Be this distance here.
Which is?
Half of the circumference that we learned about last week.
Yeah, right. It's half the circumference. So this is half the circumference.
That's that long word again.
But you're getting it. Perfect. This is half the circumference. Now, remember last week when we determined what the formula for circumference was? It's pi times diameter. So this is half of a diameter times pi. Half.
Okay, just a minute. Let me think about that again, what you said. To find the circumference, it's pi
times
diameter.
Right.
And
this is half of a circumference.
That. So I got to divide that in half.
Well, I wouldn't divide the pi. I'd divide the diameter because it's easier.
Okay. So I'm going to take, this is really the diameter divided by 2 times pi.
And what did we just see that the diameter divided by 2 actually is?
Oh, that's the radius.
It's the radius times pi.
So I can change this into radius times pi.
That's correct. So
times the radius.
Right. So the formula for area of a circle is always going to be the radius times, well, it's half of the circumference, and we've determined that half of the circumference is pi times radius. So it's radius times pi.
Or pi r squared.
Woo! Good job.
The area of a circle.
I love it. That's exactly right.
Well, I always was taught that, but I had no idea where it came from.
Well, that's exactly where it comes from.
That is so cool. I like the snack-o-vision, and I like learning how to do area of circles and circumferences with you. I wish you were my teacher all the time, Miss Glovely.
I wish I was your teacher too, Miss Wonderful.
Oh, good.
Good job.
Thank you. Thank you for joining us in another episode of Math Snacks with Miss Glovely and Miss Wonderful. Join us for the next episode next week. If you're interested in more information about math snacks, or you'd like to bring Miss Glovely or Miss Wonderful to your classroom, call Miss Glovely, Renee Smith, at 620-663-9566.